Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. I want to bring to you in this video segment something that is a bit alarming. Namely, it's about acid oceans and how acid oceans may trigger mass extinctions. Now, if you have a stable carbon cycle, life just burbles along, keeps on going. Too much carbon could wipe out many species. Acid oceans may hold the key to all of this. Though catastrophically widespread die-offs of many creatures could be inevitable if humans keep doing what we're doing, because what happens? You put more CO2 in the atmosphere, the CO2 combined with the water to make carbonic acid, but in so doing, it's decreasing the pH of the water. And we see things such as coral bleaching, but also we see the lysocline getting shallower. Now, the lysocline is a layer just like a pycnocline, a sharp change in the concentration of such chemical species like calcite, where below this layer, organisms are not able to make their shells. Above that layer, they can. Well, that layer is getting shallower and shallower, which means that more and more organisms are not able to make their shells. That puts them in danger, imperils them, increases their mortality. I did a video segment some time ago about the acid problems with the ocean. I think it's called Oceans Are Getting More Acidic. And at the end of that video, I discussed in a little bit of detail what the lysocline is. So if you have not seen that video, by all means, please go check that out. So in a new study that was led by Dr. Daniel Rothman of MIT, Massachusetts Institute of Technology, it was published in the Proceedings of the National Academy of Sciences, or PNAS as we say for short. Mass extinction, this is basically coming from the abstract, mass extinction may not be an enduring mystery. Instead, it may be an intrinsic property of the carbon cycle. Now, this is different from mass extinctions caused by rocks tumbling out of the sky. But once levels of dissolved carbon dioxide in the oceans reach a certain threshold, then life undergoes dramatic and catastrophic change. And so basically, Dr. Rothman based his argument on statistical reasoning and the evidence in the marine sediments. Then once the seas become too acidic for marine organisms to form carbonate shells, a cascade of extinctions begin. Right? And that is a reference to the lysocline that I mentioned just a few moments ago. And also, look at the evidence in the marine sediments. I did a very lengthy video on isotopic fractionation, where I discussed looking at O18, O16 fractionation, C13, C14 fractionation, and reconstructing past climates from that. But we can also do likewise, looking at the sediment cores, looking at the isotopic ratios. We can then tell you what's happened before in the past. We can reconstruct. We can then say, oh, we probably had a mass extinction event here, or at least a significant dying off taking place, and so forth. We can infer, well, if we're seeing this type of ratio in the carbon and the nitrogen, what have you, then the ocean pH is probably this, as well as the ocean temperature is probably this. And when we say probably, with 95, 99% confidence, where the data allows us to do so. So obviously, the further back in time you go, the more difficult it is. But the point of this being is that we can do a lot of reconstruction of past climates by looking at isotopic signatures. And lysocline involves the CCD, the calcite compensation depth. Calcite has carbon in it when it forms that compound. So we can easily ascertain that by looking at the carbon isotope ratio, C13, C12, as well as O18, O17 to O16 in there. So Dr. Rothman warns that the unusually strong but geologically brief duration of man-made carbon dioxide increase in the oceans can be matched with slow but devastating extinctions in the past. So basically, CO2 increases in the ocean, the pH drops, extinctions or mass die-off ensues. So extrapolate back to present day, human combustion of fossil fuels combined with destroying the forests could be building up to extinction on a scale, huge scale, that will be visible in the fossil record hundreds of millions of years from now, assuming humans are still around. Probably not. Right? Now, it's pretty much accepted that we're in the middle of a mass extinction right now that is being the result of human activity. Elizabeth Kolbert wrote an excellent book called The Sixth Mass Extinction. There's some evidence that there might have been a prior mass extinction that was not previously identified. So if that's the case, then we're in the middle of number 7. Be that as it may, there's a current mass extinction underway right now, and humans are definitely behind it. After a certain point, the carbon cycle will take over and determine what happens to life on this planet. It happened many times before, long before the humans showed up on the scene, and it could happen again. Dr. Rothman continues to state, once we are over the threshold, how we got there may not matter. Once you get over it, you're dealing with how the Earth works, and it goes on its own little ride. Now, he originally developed his hypothesis back in 2017 and was published in the journal Science Advances. So he first published his hypothesis in 2017 in the journal Science Advances, and late last year he then published, he then developed this hypothesis, did some analyses on and published his results about this hypothesis that was in PNAS, the Proceedings of the National Academy of Sciences. So it's basically 2 papers that Dr. Rothman has put out. So he analyzed 31 changes in the makeup of carbonate sediments laid down over the last 542 million years, pretty much going back to the Cambrian explosion, and connected 5 great extinctions, not just with CO2 levels, but with the rate at which these increase. How many times have you heard me stress in my videos the rate of change is the key aspect? How many times have you heard me say that? I'm always stressing that because it's friggin' true. It's the rate of change. Something climate deniers can't get through their thick skulls. The more carefully researchers looked at evidence of earlier catastrophic extinctions, the more bygone climate change has revealed itself. What caused the most dramatic and unequivocal of these? The great dying at the close of the Permian. It's still hotly debated, and I did a 2-part video series on that. But atmospheric conditions in one form or another have been repeatedly invoked, and researchers have repeatedly drawn lessons for today. For example, as an example, but arguments so far have settled on whether such extinctions are a consequence of slow but inexorable episodes of volcanic discharge or some other geological shift, for example, plate tectonics. Professor Rothman basically saying, well, I don't care about the trigger. I'm basically showing a cause and effect. Ocean acidity increases, you get mass extinction event. So he's basically saying, I don't care what caused the increase in CO2 levels in the ocean, which with the corresponding decrease in pH or an increase in acidity. I'm just simply showing that when that happens, great dying takes place or extinction takes place. That's what I'm showing. So that's what he's saying. The trigger itself may not be an important thing. What decides the fate of life on Earth is the level of carbon in the ocean and the rate at which it increases. There's that rate of change again. Once levels of acidification in the upper ocean reach a certain critical threshold, life is in for major disruption. If marine creatures cannot form shells, tests we sometimes call them, they are at risk. But even more dangerously, shells sink to the ocean floor, effectively removing carbon from circulation. If there are fewer calcifying organisms, then less CO2 is removed from the atmosphere and the oceans become even more acidic, a vicious cycle, a vicious positive feedback mechanism cycle has begun. So in other words, when organisms are able to form their shells, they die. Those shells eventually sink to the ocean bottom. That is a way to sequester the carbon. If they can't make shells, that carbon doesn't get sequestered. That carbon stays in the water, making it more acidic, making more and more organisms unable to make their shells. And there's your cycle. There's your positive feedback loop. Professor Rothman does indeed say it is a positive feedback. More carbon dioxide leads to more carbon dioxide, which leads to increased acidity of oceans, and then that leads to dying. The question from a mathematical point of view is such a feedback enough to render the system unstable? In his mathematical model, once carbon levels reached a critical threshold, a cascade of positive feedbacks amplified the effect severe ocean acidification set in. The effect was not permanent, but after tens of thousands of years, the carbon cycle did slip back to equilibrium. Life could evolve and adapt again. But this is at the mass extinction. Carbon is now entering the oceans at an unprecedented rate over what, in geological terms, is a very brief time span. If human-triggered greenhouse gas emissions cross a critical threshold, the consequences could be as severe as any of the previous mass extinctions. It's difficult to know how things will end up given what's happening today, Dr. Rothman said, but we are probably close to a critical threshold. Now, another thing to keep in mind, many phytoplankton make shells. This will affect phytoplankton. So we're not talking about mollusks, those kind of creatures. We're talking a lot about phytoplankton. Phytoplankton provide somewhere from 50 to 80% of the oxygen in the atmosphere. They start dying off, the oxygen levels are going to start dropping. It's easy for humans to say, oh, it's just the ocean, who gives a shit? We need the phytoplanktons. They help keep us alive. This will have dire consequences. And the fact that we're seeing acidification, the fact that the lysocline has already been measured as becoming shallower, things are underway. So this could be one of several factors that will make human civilization untenable. So there you have it. The burning fossil fuels put CO2 in the atmosphere. The CO2 gets absorbed by the oceans, increasing the acidity of the oceans. Organisms die, leads to a mass extinction, but those organisms that die could ultimately lead to our own extinction. Now, granted, as ocean temperatures warm up, the solubility of gases decrease, so after a while, the oceans will not be able to absorb any more CO2, and if warming continues, some of the CO2 already dissolved will outgas back into the atmosphere. Now, Dr. Rothman, I don't think considered that scenario in his modeling. It would be interesting to see if he did what his findings indicate. But nevertheless, don't look at that as like, ooh, that would be a way to save our bacon. No, because you still have the issue of decreased productivity in the oceans. And you're still going to have organisms dying off. You're still going to have the phytoplankton dying off. And we're seeing that. And that impacts us directly. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.